another day, another stream. Right, we have this set of exercises, and right now it's imaginary numbers. You have this, and what exactly do you need to get the z number? Perhaps that. So in order to get the z number, we would need to just use the property I to the second power is -1, and so like this, split the imaginary parts and the real parts. First up, we're gonna remove a parenthesis. It's gonna be x plus I to the second power on the actually x plus x I to the second power in first one, and yeah, like that. Actually x I, yeah. Alright, so plus 2y, and then minus 3i and y equal with 3 minus 2i. That's that. Now we're gonna switch the sign right there before the x I to the second power and remove the I to the second power for obvious reasons. So that's exactly how it's done. It's being displayed here on the screen. And now we can move on to the next thing, which is, like I said, working with imaginary and non-imaginary numbers. So here the condition is actually to find what is x and what is y. So we're gonna move on to that. Like I said, splitting the imaginary real parts, and when you write down the imaginary ones with the I, you don't actually write down the I. That's all it is. It's actually solvable by a second grader in China, so yeah, I think you should handle this. So -2 are right there, and now solving this system by getting what is x, for example, and then swapping it in. Okay, so we have this, minus x is that, and now we will remove a minus in order to be more convenient, and we have received this, minus 3i, actually y, and that is minus y equal with 1, right? And we can swap the sign and we'll get that y is -1. What the hell is that 1? Anyway, we're just gonna plug it in, and x is gonna be -5, just like that. And now we just write down the response. That's all solved. Now we have to solve this inequation, which is a bit complicated. Here the domain of admissible values should be associated with what's in the parentheses, all to the basically bigger or equal to 0, and as it is LG, that's basically log to the 10 base of 10. So we have the same base here, and we can work with it by just working with what's in the parentheses, and then we're gonna do the graph, pop the dots, so on. This is what we'll do right here. Alright, so let's get this straight. DVA actually is bigger than just 0, not actually bigger or equal to. Like I said, I don't know the conditions so well, so I'm just assuming. Now, first one is just like that, and the second one, it will be bigger than -4, right? And so we can switch the sign, all the signs, and it should be x smaller than 2, right? Actually, it can also be -2, as -2 to the second power is also 4. So that's how the condition is being written out. X right there in the middle, bigger than -2 but smaller than 2. And now we're just gonna plug in the values right here. We have an uncolored circle, as this is not bigger or equal, stuff like that. -2, 0, and 2, that's the DVA values. That's that. And now we just get the values that are all crossed together. So basically from 0 gotta be bigger all the way. Then we have from basically bigger than -2 all the way, and then lastly from 2 till minus infinite, so we should be actually from 0 till 2, stuff like that, right? That's where all the values are being intersected. So he's writing down the DVA as from 0 till 2. So I got that right. Now we work actually with this LG stuff. Okay, so I don't know what she's saying, but anyways, you get a point. This is just providing some examples. So like she explains why you can actually just ignore the LG and work like this. Now we will receive this if we move everything to the left, and we can equal that with 0, and then we're gonna solve the quadratic. We're gonna put a graph and match the values with DVA. So naturally we have 25 right here, and we have received -4. Now the second one will be just 1, as it is 2 divided by 2. So we have his values, now plug them in. First leave the -4 to the left, and then the 1 more to the right. And it's a color dot because it's smaller or equal in the condition right there. Okay, so next up, that's the DVA value. We pop it right here, right? Should pop it right here. Come on, what are you saying? Let's go. Less explanation. Okay, come on. So there we have the interval right here. From -4 till 1. And yeah, this is the interval. Now we just see the other one. So the other one is from 0 till 2, and where they are intersected is from 0 till 1. So that is a value. The 0 has the normal parenthesis, the 1 has the parenthesis that is not normal, and that's that. We put the euro sign from 0 to 1 like that. That's essentially the interval right here. Okay, now next up is something with trigonometry, which obviously I'm gonna skip because this average stuff is hard enough for me. I don't need to go in trigonometry. So let's see where that disappears. Still in progress, or is that something else? I think that's that's an equation right here with log. I skipped perfectly. Alright, so we have 2 above a base of log. Haven't worked with such exercises, so I'd like to see how this is done. Obviously not out of interest. So we have, looks like the same base, 3 and 3. I don't even want to assume how it's done. I'll just watch it because I don't really know what you should do with the 2 right here. So it starts off with dBA, obviously. That's going to be bigger than 0, as we have discussed in like the previous exercise with conditions. Okay, so dBA. So what do we have here? If we work with this graph, it's gonna be essentially x bigger than 0 right there, and like what else can you do here? I don't know, whatever conditions. X must not be 0, that's the condition. So I guess that makes sense because you cannot put a 0 to a power of 2 and stuff like that. You can put something at a power of 0 that's going to be 1, but you can't put the 0 as the base of exponent. So now let's see how this is done with 2 right there. Obviously using ChatGPT, this guy, for guidance, and now if we have -3 or 6th power, that is this or what? I don't know what he explains. log. So basically we're just gonna ignore the 2 right there. I mean, perhaps I need to understand how this is done, so I might take a small break for this occasion. So I'm gonna be back with the result of how this is done. Okay, so I do absolutely get it now. I'm gonna tell you how it's done. So this 2 right here, it actually means to second power all this thing. So you just do the formula, the thing that's on top minus the other thing, just with log, and all of this to the second power. That's all it is. Okay, so
Minus.
we have
And
to save this. Close the sound. So after this we have everything to the second power right there. So I think now we just remove the second power, but I mean, is it actually the formula a minus b all to the second power? It could be that formula. So yeah, let's see if it's like this. Module something. So basically just put the thing up front, the power. Let me see. This is some geek stuff. 6 right there. X like that. So the power, you just moved up front, yeah. But actually pop the volume of module on the X. And now looking over to the left, the 2 goes up front, yeah. And why is it 2 right there? Because 3 at second power right there, so only the 2 remains, as log 3 base and 3 gets simplified, just 1. And this all to the second power still remains right there. And this is what we have so far. Okay, this is what we have so far. So let's move on to this. Alright, so we have the log3x. What he wants to do is just to write it down as a t, and then we're gonna work with that, right? So we'll have that, and we'll use a formula, and we will expand the stuff, and we will get what we need. Okay, so we have received this when we have swapped that expression with t, and now using the formula we will have 8 stuff like that, right? 8t plus 4 plus 16 minus 4. So essentially we're going to get a quadratic, so we'll work with that. We'll get minus 2t, and that's it. We don't have a third term, so we just pop the 2dt, and we will have 2t minus 1. So 2t is equal to 0, or 2t minus 1 is equal to 0. And t is equal to 0 right there, and right there is going to be equal with 1 divided by 2. But that's not actually the x, that's the t, so we need to swap the t back. So we're going to swap it back. log3 module x equal with 0 in the first one, and then equal with 1 divided by 2 in the second one. And module of x is going to be 3 right there. Why? Because log3 that's just nothing, I guess. Yeah, yeah, power 0 because I guess log free of 1 is, oh yeah, because the 3 simplifies like that and only the 0 remains, so pop that. And now the second one is just gonna be free of power of 1 divided by 2, right? Yeah, so module of x is 1 right there. And if we pop that, square root of 3. This is some moderately advanced stuff. So let's just get on with it. Solutions. That's that. As it is a module, you just pop everything, but without, I mean, minus and the plus variant. I don't even remember what the DVA is, but anyway. What it's gonna do now, perhaps just a probability problem. So I'm gonna read it right now. There's a set of numbers from 1 till 5, and 3 numbers are extracted from basically this set. Find probability that, what the fuck is this problem, bro? The probability that the numbers extracted represent the lengths of a triangle. Like, come on, man. You gotta be kidding me. What lengths of triangle? How am I supposed to know that? If it's a triangle, then I don't really know how this one's done. Just gonna watch it. I could try guessing, but should be wrong, so I'm just gonna go on with it. And let me get some lights also. Give this screen right now BRB. That took a bit longer than expected. Anyways, I was saying that I don't really know how this one is done. So let's see how this probability thing is solved. You have a typical formula, m divided by n. Now what? Gotta be right there. I don't know what's written there. Move your webcam, bruv. There we go. Bro, he's literally writing down the condition, which is not obligatory, and I think it's not helpful. I already have this in my head. It's better here as you don't see the condition, it's moved, the screen is moved. So basically popped the combinatorics from 5 till 2. And that does make sense. Why? Because I mean the 5 makes sense. There are 5 numbers in total, but why 2? Because I'm taking free numbers, don't I? Let me see the condition. Go back a bit. And free elements are being extracted. So why that? God damn it, I gotta understand again. BRB screen. Alright, so this guy messed up again. It's basically free, like I said, because we're extracting free. So when you pop that, and you will get exactly what he has here. So that's been right here. 10. He did mess up there. He said 5 minus 2 exclamation mark. Actually should be 5 minus 3. But anyway, the result is how it should be. And we have N now. Now the M, I don't know how that is done. The N, I think I would be able to understand how it's done, but the M, I really don't know. Skip a bit. 123x, 134x. What kind of, okay, what kind of x? This time is gonna be different. New check.